Hey everyone, in this lesson we are going to start with our first micro project. So what I've got here is the Unreal Project Browser. Pretty much when you launch it from the Epic Games launcher, you should have this window open. Now I'm going to go down to the Games tab here. I'm going to select the blank template. We can give it a project name, we can choose the location where we want to save it to, and then we can click on the blue Create button right here to create our new project and open it up inside of the editor. Okay, and here we are. So we have created our project, the editor is now open, and first things first, we need to go down to our content drawer here, and I'm going to create a new folder which is going to basically store all of the assets for each of the different mini projects we're going to create. So the first one, we can right click, go new folder. I'm going to call this one Popper, okay, and this is going to be our Popper project. Now, what we need to do then is create ourselves a new level because we don't really want to be working with our Popper project in this scene right here with these tables and chairs and everything already set up for us, okay, so we're going to create a new level. So to do that, we're going to go File, New Level. I'm going to select Basic right here. Click Create, and that is going to create ourselves a brand new level right here, okay? So we can navigate around it just like before. We got our lights, we got our ground, we got our skybox. I'm then going to go Control S, or you can click on this little save button at the top left corner here to save this level. I'm going to go over to our Popper folder, and inside of that, I'm going to save this as Popper level, okay? Hit save, and there we go. So it's saved. And now what we need to do is create the actual thing that we want to pop. And in our case, that might be a balloon, for example. So what I'm going to do is I'm going to open up our content drawer, open up the Popper folder, and I'm going to right click. I'm going to create a new blueprint class, and we are going to make it of type actor, okay? We don't really need to give any controls. We're not going to be moving it around the keyboard. It's not going to be walking around our scene or anything. So it's just going to be a basic actor, okay? And I'm going to call this one, we'll call it balloon, okay, like so. Then what we can do is double click to open it up inside of the blueprint editor right here, okay. It's its own separate window, so we can click and drag on this balloon tab to dock it over in the main tab group, pretty much like a web browser, okay. If you've used a web browser, you should know, the general structure of how tabs and windows work, so we can do it just like that. Now, inside of the balloon blueprint editor right here, what we need to do is, well, create our blueprint. So for this, what we're going to do is we are first of all going to create a 3D model. So we're going to go add, and I'm going to create a sphere. So we can search for sphere. There we go. We got one right there. We've created our sphere, and that's pretty much all we need to do for components for this blueprint. Okay, we pretty much just need a static mesh component, which is going to represent our balloon. Now, along with this, we might also want to give it a different color because right now it's just this white color, yet balloons, they're red, green, blue, all that. So we can go down to our materials tab right here in the details panel after selecting the mesh, and we can choose a material here, but it doesn't really have the material we want. So what we can do is we can actually go ahead and create our own material. Now, do be warned that Unreal's material editor is, it can be quite complex. You can create very, very detailed and specific materials with it. Yeah, in our case, we just want to give ourselves a colorful balloon. So what I'm going to do is I'm going to go to our content drawer here. I'm going to right click, and I'm going to create a new material, okay? And I'm going to call this one balloon material. Now, a material is basically a texture or a visual look that we can give to a 3D model or an object, okay? It basically determines how the pixels of our sphere are going to be rendered on our screen, okay? So we can make it translucent, we can make it glow, we can make it wobble, pretty much whatever you want to do, you can do with materials. So I'm going to double click to open that up inside of the material editor here, and you may notice that it looks a bit like the blueprint visual scripting. We got nodes, we can right click, we can create new ones, yet all these nodes and the general way that we go about making it is very different, okay? So we're not going to spend too much time here because you could have an entire course going over materials and how to create them. So what we're going to do is we are just going to make it so that we can plug in a color to our material. So what I'm going to do is I'm going to right click and I'm going to search for a vector parameter right here, okay? Vector parameter. And basically what this is basically a node where we can give it a color. And you see here that we have the different outputs, okay? Now, these different outputs, the white one is basically going to output the red, green, and blue values, okay? So all of them together to make up the color. This red output is going to output just the red channel, the green channel, the blue channel, and the alpha channel, okay? So transparency. Now, to make this simple, all we're going to do is click and drag on this first output and plug that into the base color input of our balloon material node right here, okay? So the base color, we are basically setting that, and to change it, we can just double click on this little black box here. We can then modify the color to whatever we wish, so we might want a nice reddish, something like that there. We can click OK, and we should see that our balloon now looks like this. Okay, so we have our balloon material set up, okay, nice and basic. Pretty much we're just giving it a color. We can go ahead, click on the save button right here. That's going to save this material. It may take some time. We are then going to go back to our balloon blueprint right here. And in the balloon blueprint, what we need to do then is click on our sphere, go down to material, drop down here, and we are just going to select or search for our balloon material. And there we go. So our sphere now has this balloon material, which is great. Okay, and whatever changes we make to that material in the material editor right here, those will be applied to the model. So we can click compile, we can click save. We can then go back to our popper level here. And what I'm going to do is I'm just going to go into our content browser and I'm going to drag in a balloon. Okay, I'm going to drag in a balloon like so. We can then copy it or duplicate it with Control D. We can then move this over here. We can create another one, move it over there, maybe lift it up a tiny bit, and just create a few different balloons here that we might want. Okay, like so. Now, if we go up to the top here and click on the play button, you'll see that we press play and, well, nothing really happens. We can, go into this little camera here, zoom around, have a look at our balls, but nothing's really happening, okay? So one more thing we're going to do is we are going to give them gravity. So let's go to our balloon blueprint right here, select our sphere, go down, and where it says simulate physics, we want to enable that. Okay, so now this balloon or this ball is going to be affected by gravity, collisions, it's going to be rolling around. So we can compile that, save it, back to our popper level, press play again, and as you can see, they all fall to the ground, like so. Alright, so in the next lesson, what we are going to be doing is we are actually going to be setting it up so that when we click on these balloons, they will start to increase in size, and then eventually, once they reach a certain threshold, they will pop. So thanks for watching, and I'll see you all then in the next lesson. Welcome back everyone. In this lesson, we are going to be setting it up so that our balloons can increase in size and then eventually pop. So let's go over to our balloon blueprint right here, and we are going to go over to the event graph, okay, where we have our visual scripting. Now, what we're going to do is we aren't going to actually be detecting mouse clicks inside of this blueprint, okay? The individual balloons aren't going to be checking for mouse clicks. Rather, we're going to have a separate blueprint, which is going to be the player controller, which is going to detect mouse clicks. It's then going to determine which balloon we have clicked on, okay, which instance of the blueprint we have clicked on, and then it is going to send a message over to the balloon to tell it that it has been clicked. So how do we do that, and how do we set it up to receive that message? Well, pretty much we are going to create a function that the player controller is going to call on the balloon that it clicks. So what we need to do is create ourselves a new function, okay? So down here inside of the My Blueprint panel, what I'm going to do is I'm going to go over to the Functions tab here, click on a little plus here, and we are going to create a new function. And let's call this one increase size like so, okay? So it is called increase size, and a function is basically a set of nodes that can get triggered whenever we wish, okay? So at any time we can call the increase size function here, and it is going to call whatever structure of nodes we have. Okay, it's kind of similar to an event here, In our main event graph, we have begin play, which gets triggered once at the start of the game. So that you can think kind of as a function, yet not really. A function can be called multiple times whenever we wish. So what we could do is string this increased size function multiple times in a row if we want to. And overall, it just makes it so that you don't have to create a lot of copies of the exact same nodes. Okay, so if you ever see that you are having a bunch of nodes that are very similar, you can put it into a function and just call that function multiple times. It saves space and it saves time. So inside of this function, what we want to do is increase the scale of our sphere here. Okay, so if we select our sphere, you'll see down here we have a scale property, and if we set that to 2 or 21, you'll see that our sphere increases in size based on that scale number. So what we need to do is when this increase size function is called, we want to increase the scale. And to do that, what I'm going to do is I'm going to click and drag from the control flow here into a set world scale 3D node right here. And make sure that we have our sphere here connected to the target, okay? Because the sphere model is what we want to increase in size. And then down here, you'll see that we have another input, and this input is basically going to be the scale we want to set. Now, we don't want to manually set the scale right here, rather we want to increase it over time. So how do we do that? Well, pretty much what we want to do is we want to get our current scale, and we want to add, for example, 0.1 to it, okay? So every time this function is called, we want to set the new scale to be whatever the current one is plus another number. So to do this, I'm going to right click and I'm going to create the get world scale node for our sphere. So the get world scale node, basically this is just going to get the current scale of our sphere, and we're going to plug that into an add node, okay? So we'll create an add node here, and then we'll plug that into new scale. So now we can add a number down here, okay, along the X, Y, and Z axes. So I'm going to make that 0.1 on the Y, X, and Z values here. So pretty much what we are doing right now is when set world scale 3D is called, it's going to look for the target to set the scale for, which is our sphere. And then it is going to have another input, which is going to determine the new scale. And that new scale is going to be our current scale plus 0.1 on all axes. So every time we click on our sphere, it is going to increase its scale by 0.1. Then what we need to do is we need a way of checking to see if the scale has reached a certain value. So I am going to then plug the control flow into a branch node, which can take in a Boolean value, okay, a true or false condition. And if it is true, then this control flow will output. Otherwise, the false control flow will output, okay? So what is the condition that we want to check? Well, the condition is going to basically be if our world scale is greater than a certain value. So we can still use this node here. I'm going to branch that off here, and I'm going to create another node called vector length, okay? Now, vector length is basically the length of this vector. And what that basically means is it gets the X, Y, and Z values, and it basically determines how long it is. So if we have an X, Y, Z of, let's just say we have an X of 5, a Y of 0, and a Z of 0, that is going to be a vector length of 5. If we have a X of 2, a Y of 2, and a Z of 0, and that's going to basically, use Pythagoras to determine the length of that. So it's going to be somewhere around, 2.3, 2.4, or something like that. So basically, vector length is just an easy way to get the length or the magnitude of this vector. We're then going to plug that output into a greater than node, and we want to see if this is greater than a number such as 3, okay? So if our scale vector length is greater than 3, then this is going to be true, otherwise it's going to be false. Then what we can do is go back to our branch node here, and if that condition is true, what we want to do is we want to just destroy the balloon, okay? Later on, if you want to add maybe a particle effect or a sound effect, like a popping sound, you can do that. But for us, we are just going to destroy the actor, like so, okay? So create a destroy actor node like so, and that should be everything set up and ready to go. So pretty much what we are doing here is we are, first of all, whenever the increase size function is called, we are setting our world scale to be our current scale plus 0.1 on all axes. Then what we are doing is we are going into our branch node where we are checking a condition, and that condition is whether or not the length of our world scale, okay, the vector length, is greater than 3. So if it's greater than 3, it's going to be true, thus destroying the actor. Otherwise, if it's not greater than 3, then we're just not going to do anything, okay? We're just going to increase the size and leave it be. So now that's all compiled, in the next lesson, we are going to be creating our player controller, which is going to be detecting clicks from our mouse. It's then going to determine which of these balloons we have clicked on, and it is then going to basically go into that balloon, and it is going to call the increase size function. So that's what we're going to be working on in the next lesson, and I'll see you all then. Welcome back everyone. In this lesson, we are going to be setting up our player controller, which is going to allow us to actually determine which of these balloons that we are clicking on, thus calling their increase size function. So what we're going to do is we are going to go ahead down to our content drawer here, and inside of our popper folder, I'm going to create a brand new blueprint class. And this is going to be of type player controller, okay? And a player controller is generally used to detect inputs, call certain events or functions depending on those inputs, okay? So for example, if you had like a multiplayer game where you had multiple people with different controllers, the player controller blueprint would be in charge of determining, which control is determining which player. So we're going to create a player controller right here, and I'm going to call this one our popper controller. Then what we can do is we can double click on it to open it up inside of the blueprint editor. We can just ignore the camera right here and instead go over to our event graph. Now inside of the event graph, what we're going to do is we first of all need to make it so that our mouse is visible, because if we go back to our popper level and press play, you'll notice that if we click in our scene, our mouse disappears, okay, and we can't really get it back. So what we need to do is we need to make it so that our mouse is visible at the start of the game. So what we're going to do here is we're going to go over to our begin play node here, which basically executes its control flow once at the start of the game. So we're going to drag that out, and we are going to create a new node called set show mouse cursor and tick that box like so. Okay, so now at the start of the game, our mouse should be visible. Now, we can't really test it just yet because we do need to do a bit more setup, but we are going to check that out very soon. Next, we have the event tick node, which we are actually going to delete since we don't actually need that, and instead we are going to right click and create a new node called left mouse button. Now, left mouse button, basically this is an event node which gets triggered when our left mouse button is pressed or released, okay? Now, we want to do stuff when it gets pressed. So when we press down on our left mouse button, this event here is going to execute. And what we want to do is we want to do something known as a raycast. And a raycast is basically like a laser beam, okay? You can think of it like shooting a laser from a certain position along a certain direction. And whatever that laser hits, it can tell us information about it, such as how far away it was, what we hit, the position of the object, and other information. Now, in our case, what we want to do is we want to basically shoot a laser from our mouse cursor into whatever direction we are facing, okay? So in our case, if our mouse is over here, then we're going to be shooting a laser off into the direction it is facing. And pretty much what we want to do here is we want to check to see if that laser has hit a balloon. So how do we do this? Well, what we're going to do is we're going to create another node here, and this one is going to be called get hit results under cursor by channel, okay? It's quite a mouthful, that node name, but that is the node that we need. And basically what this is going to do is it is going to get a hit result. So a hit result is a raycast hit, which is basically, like I said, like a laser beam that we're shooting. We can give it some properties here, such as inputs, but we're actually going to leave all of those as they currently are. And instead, we are going to go to this hit result output, and we're going to drag that out, and we're going to plug this into a hit result node like so, okay? Break hit result. Now, what this basically does is this allows us to have a look at all of the different outputs that it can give us. Okay, so when we call this hit result, okay, once we shoot off this laser, it is going to return to us a hit result which contains a bunch of information about the object we hit, such as, the time that we hit it at, the distance, location, the impact point, the normal, the actor that we hit, the component that we hit. So pretty much you can get very specific with your hit results here. Now, what we want is the hit actor, okay? And we want to know whether or not this is a balloon, because right now we could be hovering over the ground and the hit actor would be, the 3D model of the ground. And we don't want to try and call an increase size function on the ground. That's going to, return to us some errors. So instead, what we want to do is drag out from hit actor, and we are going to plug this into a cast to balloon node. Okay, so cast to balloon. What this node here is doing is basically it is going to take an object as an input. It is going to try and convert it to a certain type of blueprint. Okay, so it's going to try and convert it to a balloon. If it is able to convert it to a balloon, this control flow is going to output. Otherwise, the cast failed is going to output, and that can then, log an error, or in our case, not do anything. So I'm going to plug the left mouse button pressed into cast to balloon. Now, if the object that we have clicked on is a balloon, then this control flow is going to be called. And in that case, what we want to do is we want to call the increase size function of our balloon. So I'm just going to type increase size. It's going to create that node here. And then what we want to do is plug the as balloon output into the target of the increase size function. Okay, so it knows what balloon to call that function on. So there we go. That is how we can detect inputs from our mouse. Then what we are doing is we are shooting a laser from our mouse towards wherever we are facing. It is then going to take the actor that we hit. It's going to try and cast it to a balloon. So it's going to try and convert that to a balloon. If it is a balloon and it converts well, then we're going to call its increase size function. Otherwise, we're not going to do anything. Now what we need to do is we need to actually have this controller work. So I'm going to click compile. I'm going to return back to our popper level. And what I'm going to do is I'm going to create one more blueprint, and that is going to be our game mode. So game mode base is going to be the parent class, and I'm going to call this one our popper game mode. Now, the game mode blueprint is in charge of basically determining, the various settings and overall game functions of our level right here. So I'm going to double click to open that up. And inside of the game mode, what we're going to do is go down to the right-hand side on the details panel. And you'll see here we have a player controller class, and this is where we can assign our popper controller. Okay, so the popper controller is assigned. We can then click compile. We can then go back to our popper level, and if we go over to the world settings tab right here next to our details panel, if you don't have that, you can go up to window and then down to world settings here to open that up. And pretty much what we want to do is go down to where we have the game mode override. We're going to click on where it says none, and we're going to set that to be our popper game mode. So what we are doing there is we are basically giving this level here the popper game mode, and that popper game mode has set, if we click here, it has set the player controller class to be that popper controller which we just created. So when we press play, this popper controller is going to be active, and it is going to basically be receiving these event calls. So that's quite a lot to set up some mouse inputs, but that's what you need to do with Unreal. So now what we can do is we can make sure that everything is compiled, go back to our popper level, press play. You should see that the mouse cursor is also now visible, which is great, meaning that the popper controller is working, and we should try then click on one of these balls. So I'll click on this balloon here. As you can see, the size is increasing, and after the length of that vector has reached 3, it should then pop, like so. We can go along and do that to all of the other balloons as well, like so. And there you go, that is our basic balloon popper minigame set up and ready to go. Now in the next lesson, we are going to be looking at loops. Hey everyone, in this lesson, we are going to have a bit of a challenge, okay? So we have our balloon popper game here, But what I want you to do is have it set up so it looks like this, okay? When we click on the balloons, they jump up into the air, as well as increasing in size. And then after they pop, they explode like so. Now, this may look very complicated, okay, but it's only a couple nodes really that we have to use, because Unreal's blueprint system does a lot of stuff for us, okay? So on screen right now is the list of nodes that we will be using, okay? So when we click on a balloon and it is not going to pop, we want it to jump into the air. Yet when the balloon is popped, we want it to basically have an explosion effect, okay? And we are gonna be using these nodes on screen in order to accomplish that. Okay, so here inside of our balloon blueprint, I want you to have a go at trying that challenge, okay? It may be a bit hard, but it will introduce to you a couple new mechanics of Unreal. So I'll be right back to see how you're done. Okay, so I hope you had to go at that challenge. Pretty much what we want to do is we first of all want to have that explosion effect. So what I'm going to do is I am going to remove this connection between destroy actor and the branch node by just right clicking on our branch node and going down to where it says break node links. We'll just reconnect these ones here real quick. And then in between this, we want to create a node called spawn emitter at location, okay? And an emitter is basically a particle effect or an effect that we can spawn in. Now, if you did start your project with the standard assets that came included with Unreal, then you should have a couple particle effects already built in. So from true, I am going to bring this into the spawn emitter at location and then plug it into destroy actor, okay? We can't destroy the actor first, then emit at location, because it's going to have issues with trying to find the correct location, all right? So over here in emitter template, we can click on where it says select asset, and I'm going to choose the P_explosion, okay? So that's the explosion particle effect. Now we need to give it a location to spawn at, and we want it to spawn at, well, our balloon's location. So I'm going to right click and I'm going to create the get world location in brackets sphere. Okay, that's going to create this node here with a little sphere input. We're going to plug that into location like so, and that is the explosion effect set up. Okay, spawn emitter at location, that's pretty much all we need in order to create a particle effect, and then you can modify things like the rotation, scale, does it auto destroy, and is it auto activated, stuff like that. So we can compile, go to our level, press play, and now you'll see that when they pop, they have that explosion effect. Now, how do we set it up so that the balloons sort of bounce up in the air? Well, that is by interacting with the physics system, okay? Now, if we select our sphere here and go to the details panel, you'll notice that under the physics tab here, we have simulate physics enabled. That is why our spheres fall to the ground at the start of the game, because they're being affected by gravity. Now, as well as this, there are a bunch of nodes that we can use in order to interact with the physics system. One of those nodes is the add force node, okay? So add force in brackets sphere. We want to create that here, okay? And then from the false output of the branch, so if we are not ready to pop, we'll plug that into add force like so. And then what we can do is we can give it a force vector. So basically the direction and amount of force that we want to apply. Now we want to basically shoot our sphere up in the air. So we're going to go over to the Z value, which is verticality. And I'm going to set this to something such as 15,000, okay? And then also make sure to enable accel change, because accelerate change basically means that we are changing the acceleration so that the effect is much more punchy rather than a slow, gradual increase of speed. We are basically whacking it like a golf ball, all right? So we can compile that, go back to our level, press play, and now when I click on this balloon here, you'll see it bounces up in the air a bit and then pops, like so. So yeah, that's just how you can add some extra game feel and sort of responsiveness to your game elements. Okay, particle effects. We have the size increase. We also have the popping. As well as this, you can also maybe add in some sound effects to make it, you know, a pretty immersive experience. So yeah, that is a look at how we can spawn particle effects like so, and also adding force to our physics objects. So thanks for watching.